Let's look at this question. In this question, it says when 120 ml of ethene gas, so 120 ml of ethene gas, is mixed with 60 ml of oxygen gas, an incomplete combustion reaction occurred as shown by the equation. If the temperature and pressure were constant, what would be the final gas volume expected? So if the temperature and pressure are constant, so if you use PV equals to nRT, temperature is constant, pressure is constant, R is constant, so volume is directly proportional to mole ratio. So it means if it is 120 ml and it is 60 ml, then oxygen is going to be the limiting reactant. Which means 60 ml of oxygen will need 30 ml of ethene to be reacting with it. Now, if 60 ml of oxygen, 30 ml of ethene, then if you look at 1 to 2 ratio, then this will also be 60 ml, same ratio, and this will also be 60 ml. Which means now, obviously, this has reacted, so it's gone. So the products are 120 ml, but you also have 90 ml of ethene remaining because only 30 ml reacted, right? Because it was an excess, so this was excess. So 120 ml plus 90 ml, the answer should be 210 ml of the final gas volume expected. Another similar question. In this question, they said 100 mils of ethane gas, so 100 milliliters of ethane gas, is mixed with 500 milliliters of oxygen gas at a certain temperature and pressure. Now, what is happening after the reaction had cooled to the original temperature and pressure, which means temperature and pressure are constant from initial to final, which means it's the same situation. PV equals to nRT, temperature constant, pressure constant, R is gas constant, so volume is directly proportional to moles. Now if you look at here, it's 2 to 7 ratio. So it means if this is 100 mil, this should be this should be 350 mil that you will need. So 350 mil and 100 milliliters. This will be reacting. It means all of this will be reacting, but from oxygen we had 500 milliliter at the beginning, but only 350 is reacting, which means 150 milliliter of oxygen is remaining. Okay, which means now if you look at the mole ratio, this is 2 and this is 4. So if this is 100, that should be 200. So this should be 200. And if it's 2 to 6, which is 1 to 3, so it should be 300 milliliters from 100, right? So this is the total volume of the product, 500 milliliters. But they are asking total volume of gas present. It includes both reactants and products, which means 500 mil plus 150 mil, that will give you the total volume, which is 650 milliliter. That will be the answer. So in this type of question, it's very similar to stoichiometric calculations. The only difference is that instead of using moles, you're using volume to calculate the stoichiometric ratio and all those things, because volume is directly proportional to moles.